Okay, so let's take with respect to testing. Now let's talk about the difference between integration testing, alpha testing, acceptance testing, and beta testing. Now these different testing phases represents the different stages carried out while a program or a software solution is being tested and eventually being delivered to the client. So basically, what happens is that when we're working on a software, the stepwise refinement that we discussed previously dictates that the problem has to be divided into sub-problems. Each sub-problem is implemented, each sub-problem is considered a module. And if we're working in parallel, that means each module is being worked on by a separate team in parallel to other modules being working. So each team is basically working on their part of the software, which means that they are carrying out testing for that module separately. That process is known as module testing. Now, when each sub process or each module has been completed and has been tested completely, they have to be brought together in the form of a complete software. This process of bringing the modules together is known as integration. Now obviously, it's each module has been tested on their end. Each module has been cleared by the team working on that module, and it has been cleared that it's working fine. So it means that they have carried out module testing on their end, they're satisfied with their module, and they are sure that it's working fine. But what guarantee is there that when I combine all modules together, they will still be working properly? To make sure that that part is true, we have to carry out integration testing. Now, what integration testing means is that I combine all modules together and see if they work together properly, and thereby satisfy. That allows me to, establish whether or not is the software working correctly, properly as expected as a whole. Now, integration testing can be carried out, in one go, in which I simply combine all modules together and see if they work together. But preferably, it is carried out incrementally. Now, basically, what incrementally means that I combine two modules together, see if they work together. If these two work together, add the third one, see if the three work together, add the fourth one, see if the fourth one together, all four of them work together, and eventually incrementally add all modules together, thereby establishing if all modules work together. So this is the incremental approach towards integration testing, adding modules at adding one module per integration, per increment, thereby establishing the completing the whole program together and testing it as a whole. Now, when a software house has carried out integration testing on their end, it means that the developing team, the team working on that software, has established on their end the software is working correctly as a whole. They're satisfied with it. Now, the next step is alpha testing. And what alpha testing means is that I'm basically carrying out testing in the software house, but not necessarily by the same team who had developed it. So basically, I want to get a feedback from people who are not part of the development team of whether or not, and their feedback will be sort of, unbiased. They have no attachment to the software, but they are attached to your software house. Yes, they're part of your software house team, but they're not necessarily part of the team working on the software. They're unrelated to the software at project being worked on. So basically, they will test the software, they will carry out testing of the software themselves, and then they will give their feedback. But if their feedback is important, because they will not be, they're not part of their team, they're not part of the development team, they are part of your organization, but they're not part of the development team, because of which they can give you a neutral review of what they have experienced with their software. Now, why is this important? Because if there was any problem, if there were any bugs or any flaws, they can be highlighted before they land in the customer site. They are highlighted within your software house, and if there are any mistakes here, you can handle them without having the customer being involved yet. So your own software house team highlights the errors, and the errors are solved, and it is taken care of within the software house alone. It does not reach the customer yet. So alpha testing is carried out by a team that is not linked with the development of the software, but they are part of your organization. So any errors are highlighted will be kept as a secret, as a confidential secret within the organization, and they're handled there and finished there within the organization. Now, if say for example I'm working on a software that is bespoke. Now bespoke software means that I created a software for just one client. It's not off the shelf, it's not for general public. I created a software for just one client. Then after alpha testing I have to carry out your acceptance testing. Now acceptance testing means that I hand over the working software to my client, and I'm actually just looking for some feedback from the client. If the client is satisfied with the working software, then you can say that they have in general accepted it, and your acceptance testing has been cleared, your acceptance testing has been passed. So I just want to basically get my client's feedback before finally handing over the software or finally installing the software on the customer side. But important thing here is that acceptance testing is only carried out when the software is bespoke, is made for only a specific client. So this acceptance testing is the final phase before the software is finally deployed at the customer side. If, however, I am carrying out, by the way, after acceptance testing is cleared, sign off process is carried out in which the software is cleared from my side. The client has accepted that the software is complete as per their requirements and is ready to use, and they are satisfied. So it's just ready to use, and you install it on the customer side, and every other process such as training and documentation that comes afterwards is carried out, and you can basically say the software is now complete. Project has now been completed. If you, however, you're working on a general software, off the shelf software, a software that is meant for a wider audience, in that case, you do not carry out acceptance testing, because acceptance testing doesn't matter here. You don't need one customer's feedback, you need a general public's feedback. In which case, you carry out something known as beta testing. Now, beta testing, in beta testing, what we do is that we give the software in its working condition to a small group of people that represent your general public. Now, this small group of people will use your software. They will use it for some time. They will access all features of it, and they will use it freely. And after that beta testing phase, they will give you some feedback, or during the beta testing phase, they will give you your feedback, some feedback. That feedback could include some possible improvements, and it's working fine, but this thing could have been better. And most importantly, they can report any bugs if they have experienced any sort of errors. So during this time, the general public will give you feedback of the software, and based on that feedback, the software house that worked on the development team that worked on the project will work on improvements to try to eliminate those issues highlighted by the beta testers. After the beta testing phase has been completed, it means that you have taken the feedback of the public, and you have tried to solve the problems raised by the public, and now the software that you have launched is possibly the best possible version it can be without those problems that were highlighted by the general public. So after the beta testing phase is completed, it means that the faults that were reported by the public have been solved, and hopefully it will be now launched to an even wider, it's now available to everyone. So this is a better approach when using when you're creating a software for the general public. Usually we know we're familiar by the beta version, the concept of beta version for software basically means the earlier release. Whenever we launch, when a new version for Android is launched, it's only launched to, say for example, Pixel and Nexus devices, and it's not available to other Android devices. Why is that so? Because that software is in sort of in a beta testing phase right now, and any Pixel user, if they feel any bugs, often people don't install it. Pixel users don't install it because they know it's going to have faults in it because it's in the beta testing phase. But when the beta testing phase is over and Android has finalized the software and they're satisfied with it, they have taken the general public of the feedback, sorry, feedback of the general public, they will launch that Android version to all other devices as well. Samsung and every other device will have it available too. But before that, only a small portion of the smartphone market, which is the Google Pixel devices, will have that version only on first. Now, let's talk about test strategy, test plans, and test data. Okay, basically, when we carry out a test plan, the outline of a test plan should highlight the flow of control. It basically means that if we have different screens in the software, does the the screen show appropriate choices, and when the user selects a particular option, does the screen transition to the appropriate screen or not? uh, does does my software have any validation on input? Now, if you remember, validation requires that my inputs are made sensible. So if I require only numeric inputs for a particular field, my validation should allow, validation checks should make sure that only numeric inputs are being input. If there's some sort of format being used, my validation should ensure only a certain type of format is being used. Are loops working correctly? Do they run appropriate number of times? Is data being saved in the expected places, the proper places? And does the system produce expected results? Is it working properly? So these all, things have to be evaluated when we're creating a test strategy. We have to make sure that these things are highlighted if in that test strategy. Now, when we're carrying out testing, we have especially when we're carrying out black box testing, as mentioned before, we have to work up some sort of test data to give that software, and based on that test data, the output will be giving us an idea of whether or not software has bugs or not. So as mentioned before, test data falls in three categories: normal, abnormal, and boundary extreme data. Now, normal data is valid data. That means based on the normal inputs, my program should behave normally. So let's just say under normal inputs, my program is producing errors. There's a big red flag right here where there's some logical error here. So my expectation for normal inputs is that my program should give normal outputs, expected outputs. So if it's not doing that, there's a logic error there. Similarly, if I am giving abnormal values, it should produce errors. If giving abnormal values does not cause my program to produce errors, red flag there as well, there's something wrong. Expected behavior under abnormal values is error generation. If it's not doing that, something wrong. Similarly, boundary extreme values. Now here's the thing. Extreme values is valid data. It's not abnormal values. This will not cause an error. But we have to see if whether or not my software is working properly under extreme conditions. It should. If it's not working properly under extreme conditions, it's a logic error. We have to solve that problem as well. So for example, earlier on, there is in your, say, for example, paper 2, there's an example frequently discussed here, which is the pyramid program. Now, for a pyramid program, I'll just go through it again. The pyramid program requires you to input an odd number, and just I'll show you one thing right here. The pyramid program requires us to put an odd number and a particular character, and basically the program will output a pyramid on the screen. Let me just go through that again, just a quick recap. Yes, one. So for example, we're running the pyramid program. It takes two inputs, a character and an odd number. And basically based on these two values, it generates this pyramid. The odd number that you input represents the lowest row. So if, for example, I entered 9 here, it has 9 this characters at the lowest row. And it basically starts from here and it creates a pyramid type shape based on these two inputs. Now, if this program was written, we have to test it with certain values to see if it's working properly or not. Now, for testing this program, I have a few types of test data, abnormal, normal, and extreme values that can be a value it can be used to see if this pyramid drawing program is working properly or not. So just a quick recap, this program, if written, takes inputs, two inputs, a character and some odd number. It has to be an odd number, right? So let's go back here. Okay, so for the pyramid program, again, we need odd numbers and a character. Forget the character for a second. So for an odd number, normal value for, see, I'm checking on normal, abnormal, and boundary extreme values. So for pyramid program testing, I should give 7 as a normal value. Yes, it's perfectly normal value. So if I give 7 as in the normal category, it should behave normally. It should create a pyramid with last row having 7 characters in it. That's fine. That's a normal value. However, if I want to see whether or not program is generating errors properly, I could give it erroneous or abnormal values. So for example, a requirement was positive odd number. So in this case, if I give a negative odd number, that's an abnormal value. In this case, my program should generate an error. Similarly, if I don't give an odd number at all, I give 8, an even number, it should generate an error. Finally, if say I don't give a whole number, I give a real number, that should also generate an error. So it has to be positive, odd number, whole number only. None of these matter. And finally, a fourth possibility is that I don't give a number at all. It's a character. It should cause an error. So any one of these values can be used. In fact, all of these values should be given to see if if the program is generating an error as expected. If these values are accepted, that's wrong. They should not be accepted. This should cause an error. Similarly, the fourth category is extreme values. Now, extreme values are valid values, but they lie in the lower and upper extremes of our valid range. So these are the extreme value. By extreme values doesn't mean the upper extreme. They can be the lower extreme as well. So for example, the smallest possible odd number that I can have is 1, even though it won't look like a parameter, it won't look like a pyramid, but still 1 is an odd number. That is the lowest possible odd number I can have, in which case it should accept it and should just draw one character on the screen. Similarly, using 79 or 81 should be the upper extremes. Now, for example, if I use 79, 79 will cause my, say, pyramid to be drawn in such a way. Let's just say, for example, 79. For example, when a pyramid is drawn with 79, it will look something like this. My pyramid will start from here and it will reach, sorry, not straight line, but it will reach something like this. With 79 characters, this is the largest possible pyramid I can draw on screen. See, so this is the last number. 79 is the last number for which the pyramid will actually look like a pyramid. On the other hand, if I go any odd number beyond this, so for example, I go for 81, for 81 or say 83, my shape will start looking like this. As you can see here, it doesn't actually look like a pyramid because I'm not ending it's not actually a straight line, but you see that this it looks like a rectangular shape here because even though it is a pyramid, if I had a bigger screen, you can see that goes all the way down to a vertex, but since it's not being displayed on the screen, it doesn't look like a pyramid. So 79 is the last odd number in which this shape can be created, where the ending as expected. Whereas any odd number beyond that will start creating shapes like this that don't necessarily look like a pyramid. They start look like some sort of polygon in which there's a rectangular shape here and so on and so forth. So 79 is the last value for a screen display in which it will look like a pyramid, and anything beyond that will not look like a pyramid. So the upper extreme should be, for example, for a particular screen should be 79, because beyond that value the pyramid drawn won't necessarily look like a pyramid anymore. Now, let's check out the difference between corrective maintenance, adaptive maintenance, and perfective maintenance. Okay, for okay, by the way, what is maintenance? Maintenance means that the program has been created, it has been deployed at the client side, the client's using it, and maybe the client is not satisfied with the code and may require some changes in it, and because of which he will approach you for those changes. And when a deployed program that's currently being used has to undergo some changes, that is required, that's called maintenance. Now we have three types of maintenance: corrective, adaptive, and perfective. Let's understand the difference between. Corrective maintenance means that the program was running, client was using it, and it has some errors in it. As mentioned before, it is actually the worst possible way to identify an error. But let's just say that happened and the client uncovered some errors in it, there's some bugs in it. The client identified them. If the client side identified the errors, we have to solve them. And if we're solving existing running code, if we're solving these errors in existing deployed code, we are actually performing corrective maintenance. So basically, corrective maintenance is carried out to identify, solve any runtime or logic error that may have been uncovered while the client was using the software on their end. So I repeat, corrective maintenance is carried out when we are solving a logic error or a runtime error that may have been occurred, that may have occurred on the client side when the client was using the software. Okay? So that's corrective maintenance. Then we have adaptive maintenance. Adaptive maintenance means the software is working fine. There's no problem in it. There's no bugs in it, but the client has some new requirements. So let's just say, for example, the client required you to create a software that calculates certain taxes for a particular, it's a tax calculation software. Now you have implemented the tax requirements, the tax laws in that software, and the client's not using it for their firm, tax firm, whatever it is. Now, let's just say the tax laws changed or tax rates changed. Now, because of these changes, now it's not a bug, it's not a fault if anyway, it's okay, the requirements change. Because of these new tax laws or new tax rates or new tax brackets, the client will approach you and he will say, okay, now the requirements have changed and could you please implement these new requirements? Now, if you're implementing these new requirements, you are basically carrying out adaptive maintenance, because if you don't do that, that software becomes irrelevant for the general market because it does not have updated tax laws, it does not have updated tax rules. It has to be kept up to date with the modern requirements. And this is just one example. This taxation is just one example. So if the program is working properly, but the client's requirements have changed, in that case, to implement those new requirements, the adaptive maintenance has to be carried out. And finally, perfective maintenance means the program is working fine, is producing satisfactory results, but there is room for improvement. It's often the case that, since deadlines are close and time's short and client wants to quickly solve their problems with the software tool, often we hurry into solutions. So because we hurry into solutions, it works fine. I mean, and it doesn't have bugs in it. We don't necessarily have the time to make improvements. Now, if we want to add improvements to it, we can do that. And adding improvements to an existing satisfactorily working code. It's working fine, it's not producing any errors. But if you're adding improvements to it, now improvements can be meaning that we want to make it run faster, less resources required, or for example, yeah, it's mentioned here, if we're using file access, we're using sequential access, but we want to add random or direct access right now. It's an added feature. Sequential access is okay too, but we know that sequential access takes time. If we have a lot of data, it will take long time to access data. It will do it, but does it slowly. Whereas direct access or random access does it instantly. So if we want to add this feature to it, our existingly working program, it will basically cause our program to work better. Now, these improvements are called perfective maintenance. So if at times you want your software, which is already working fine, to do a little better, it has no errors whatsoever, there's no change requirements, but you just want it to perform better, then we have to carry out perfective maintenance. So this is the last type of maintenance that can be carried out just to make improvements. Working fine, no bugs, no change requirements, but you just want improvements in it.